All right, let's just jump right in. We're going to tackle one of the biggest, most mind-bending questions you can possibly ask about, well, everything.
So let's get right to it. Does the universe have an edge? Like a final wall? A boundary where everything just stops? I mean, we always say everything has its limits, but when you're talking about the entire cosmos, does that rule still apply?
I mean, it seems like a no-brainer, right? If the whole thing started 13.8 billion years ago with the Big Bang, then it must have an end. It's had all that time to expand, so surely it's reached some kind of outer limit by now. It has to stop somewhere. But, well, what if our common sense is just wrong?
To really get our heads around this, we have to go back in time to the early 20th century, where two giants of astronomy completely rewrote the rules.
So, first up, we've got Einstein. In 1915, his mind-blowing general theory of relativity basically said the universe can't just be sitting still. It's either got to be expanding or contracting. For more than 10 years, that was just an idea on paper. But then, in 1929, Edwin Hubble points his telescope to the sky and finds the smoking gun. He sees that distant galaxies, all of them, are rushing away from us. Einstein was right.
This discovery gave us a totally new picture of everything. It's like, imagine looking at the wreckage of the Titanic, just scattered and drifting apart on a vast, dark ocean. That's what Hubble saw with the galaxies. Everything was moving away from everything else. There was no denying it. The universe was expanding.
Okay, now this next part is absolutely crucial, and it's where a lot of us get it twisted. We tend to think of galaxies flying through space, like pieces of shrapnel from a big explosion. But that's not what's happening.
The real key here is that the galaxies aren't moving in space at all. The space between them is what's expanding. Think about it like drawing dots on a balloon. When you blow up the balloon, the dots get farther apart, right? Not because they're crawling across the rubber, but because the rubber itself is stretching. That's our universe. The very fabric of reality is stretching.
But just when you think you've got it figured out, this whole simple Big Bang idea starts to get complicated. When we look really closely, some pretty big cracks start to appear.
Okay, puzzle number one. When we look out at the oldest light we can see, the afterglow of the Big Bang, called the cosmic microwave background, it's unbelievably uniform. The temperature is almost exactly the same everywhere we look. How on earth is that possible?
I mean, think about any explosion you've ever seen. It's hottest at the center, and it gets cooler as you move out, right? But not the Big Bang. Its leftover heat is perfectly smooth, no matter which way we look. That's a huge problem for the simple explosion idea. It hints that maybe the bang wasn't an explosion in space, but an expansion of space, happening everywhere at the same time.
And if that wasn't weird enough, puzzle number two comes along. So, we know the universe is expanding, but then, in 1998, scientists figure out it's not slowing down, it's speeding up. Something out there is hitting the gas, pushing everything apart even faster, and somehow overpowering gravity.
What is this stuff? Well, we call it dark energy. And it's not just some placeholder name for something we don't get. It's a very real, fundamental part of our universe. It's like anti-gravity, a force built into the fabric of space itself that's just pushing everything away. We can see what it's doing, we can measure it, but we have basically no clue what it is.
So, okay, if the universe isn't some simple explosion expanding outwards, then what is it? To answer that, we have to talk about its actual shape, its geometry. And this is where the whole edge question gets really interesting.
When we talk about the shape of the entire universe, our best measurements point to two wild possibilities. Option one, the universe is flat. And flat doesn't mean two-dimensional. It means it just goes on forever in every direction. If that's the case, no edge, because there's no end. But option two is where my brain starts to melt. What if the universe is curved, wrapping back around on itself, kind of like a four-dimensional sphere?
Here's the best way to think about it. Imagine you're walking on the surface of the Earth. You just pick a direction and start walking in a perfectly straight line. You're never going to hit a wall, you're never going to fall off an edge. Eventually, if you just keep going, you'll end up right back where you started. A curved universe would be the same idea, just in 3 dimensions. It could be finite, it could have a size, but it would have no boundary, no edge.
So what about that edge we see when we look through a telescope? Well, that's probably just our cosmic horizon. Think of it like being on a boat in the middle of the ocean. You can see the horizon, right? It looks like the edge of the world. But you know it isn't. It's just the limit of how far you can see. The cosmic horizon is the same thing. It's the point so far away that light from beyond it hasn't had enough time in 13.8 billion years to reach us yet. It's an edge to what we can see, not an edge of what is.
And all of this, it leads us to an even bigger, more profound idea. If our simple model of one Big Bang has all these problems, maybe we need to rethink the whole idea of a beginning altogether.
You have brilliant people like Professor Avi Loeb at Harvard asking a really provocative question. Why must the universe start with a single Big Bang at all? Why are we so attached to that one idea? The evidence itself seems to be nudging us towards something, well, something more complicated.
And that question just blows the doors wide open to some really mind-bending theories. What if there wasn't just one Big Bang, but many? Or what if the universe expands, collapses, and then bounces back, creating a new one? Or, my personal favorite, what if our universe is just one bubble in a massive cosmic foam of other bubble universes? I know, it sounds like straight-up sci-fi, but these ideas could actually solve real problems, like that weirdly uniform temperature we talked about.
But even with all these incredible ideas on the table, we're still stuck with one final massive puzzle. And it all comes back to that weird, mysterious stuff called dark energy.
Think about it this way. If you have a can of spray paint, as you use it, the pressure inside drops, right? The gas gets spread out. So you'd think as the universe expands and gets bigger, the push from dark energy should get weaker. It's being stretched out over more and more space. It should be getting diluted. So what we expect to see is the expansion slowing down. We think gravity would eventually start to pull things back together. But what we actually see is the complete opposite. The expansion is speeding up. That means that somehow the push from dark energy isn't getting weaker. It's staying constant, or maybe even getting stronger. This makes absolutely no sense based on what we think we know.
So where does that leave us? We're living in a universe that seems to have no edge, being pushed apart by a mysterious energy that defies our understanding. And it forces you to wonder, maybe we're asking the wrong question. Maybe the question isn't, does the universe have an edge? Maybe the real question is our universe infinite? Or is it just one tiny chapter in a cosmic story that has no beginning and no end? The answer? Well, it's still out there, waiting for us in the dark.